What is the definite integral notation of the following? You have sigma notation with a limit as n approaches infinity. You start at 1, you end at n. All of this terrible, terrible, terrible stuff. All right, so this is what we've got going on. We've got ourselves a 3i over 2. All of it is going to be squared. You got a 6i over n. Okay, when you're dealing with sigma notation, first off, let's apply that squared. So we have sigma n I equals 1, limit as n approaches infinity. Let's apply that squared so you become 9i squared over 4. You become still 6i over n. Now, when you're dealing with sigma notations, when you sigma this, okay, any I becomes x. When you sigma I over n, it becomes 1. Okay, so what's going to happen here is if we just make believe that sigma is attached to both, let's get rid of all this limit stuff and just read it. Just let's simplify it and rewrite it like this, just to make life easy. Okay, sigma, sigma. Okay, rip out a 9 over 4. 9 over 4 is sigma I squared. Okay, rip out a 6, sigma I over n. Okay, once you have that, we can now kind of apply these rules here. The sigma of I squared is going to be x squared, so you become x squared with a 9 over 4 attached. You become 1, so plus 6 times 1 is 6. When I look up here, the only one that applies to that is going to be C. So C is going to be my answer. Okay, now the reason why we have 0 and 3 is because of the way that this is graphed. If you were to graph this and do a little bit of solving, you would have just an integral between 0 and 3. But yeah, it's kind of sigma notation when it deals with these limit things are kind of gross. But that's what we get here. Fun stuff.